Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use WinCC Flexible 2008, about how to create the alarm. Okay, if we talk about alarm, there are two types of alarm. The first one is discrete alarm. The second one is analog alarm. So in this section, I would like to show and share about how to create the discrete alarm that can generate from the analog and convert to the digital, and then it will show the alarm when, example, the temperature of heat bearing of generator or earth bearing of generator is abnormal, it will show alarm. Okay, so to create the alarm, I will use the SIMATIC Manager and WinCC Flexible to create the PLC and screen to show the alarms. Okay, so let's go. Okay, so first open SIMATIC Manager. And I will use the existing project that we already learned in the previous video. So let's go to find the project name generator. Yes, it is the existing project. Okay, here. And then we can download this project to the PLC that we already learned in the previous video. Yes. Okay, so we can online. Okay. So this is an existing project that we already learned in the previous video. So for example, to create the alarms, let's create the data block. Okay, I will delete this one first. Okay, so first create the data block. To create the data block, let's go to blocks and then right click here, insert the new data blocks. Okay, and this is data block number 1, example for alarms. So the first one, we double click to create the variables for alarm. Example alarm 1, it is a boolean. Example alarm 1 for heat temperature high. Okay, and for alarm 2, it is boolean also. Initial value 0, it fall. Heat temperature of bearing, right? Heat bearing temperature. Okay, I will delete this one first. Okay, heat bearing temperature high. Okay, and alarm 4, Boolean also, initial value 0 also, earn bearing, temperature high, and for alarm, sorry, this one alarm 3, okay, alarm 4, Boolean 0, it means that fall, initial value 0, it means off, 1 it means on, okay. So earn bearing, temperature high, okay. So let's test for this for alarm first. So I will delete this one and then save the project, and then we can download. Yes, okay, and then close it. So right now we already created the data block for DB1. So we need to create the alarm here. Which one is the earn? Yes. Head bearing, yes, here. So I will compare by using this value. Example, I set this one, okay. Let me create here and use the comparator. So CMP for compare. Example, less than, sorry, greater than, yes, greater than equal real. So example, this one compare with the set point that we set. Example, 50.0 degrees Celsius. So it will generate the alarm, right? It will generate the alarm. So let me cut here, and then let me insert one more for network. Alarm of head bearing generator, okay. So I can paste here, and then I will use the contact, sorry, coil. So DB, okay, we can put here. Yes, the table here that we already created. So head bearing high, right, for alarm 1. So double click here, okay. And for alarm 2, we can insert okay, like this. This one should be alarm high, right? Okay, alarm high, and we can create one more network. Okay, and then we can use the CMP for compare. Greater than equal real. Yes. So the output the same. Yes. This one for head bearing, and then compare with the 60 degrees Celsius. It means that if the value of this one greater than 50, it show high one, yeah. And for this one greater than or equal 60 degrees Celsius, it will show alarm high. Okay, so I will use quite one more and dB, and this one alarm 2 for temperature high. Yes, here, double click. Okay, and for the bearing of head bearing, sorry, this one is earth bearing, right? Head bearing, this one should be earth bearing. Okay, earth bearing. So I will create 2 network more, and then we can use the CMP. Yes, greater than equal real. Okay, and then I will use this one, compare with example 50.0 also. One more coin, yes. So dB 1.dbd 3 for alarm 3, right? This one. Okay, and one more we can copy, paste, copy and paste for high alarm. Example 70 degrees Celsius. Okay, and this one should be alarm 4, right? Okay, and we can comment it a little bit. This one should be high. Of earth bearing, and this one should be high of earth bearing. Okay, and then we can save the project and then download to the PLC and online. And we need to create the alarm on WinCC Flexible, right? So let's go to create the alarm on WinCC Flexible. So open WinCC Flexible software, and then I will use the existing project that we already learned in the previous video. So the project name is generator. Okay, so wait a moment for opening the project. So this one is the existing screen that we already learned in the previous video. So I will create the new screen. Yes, example this one for main screen. And this one for alarm screen. Okay, so to create the alarm, first go to the object, enhance object. So drag and drop the alarm view to here. Okay, and we can resize the object a little bit. If the screen is big, it also can use easy to view. Yes, so it just example. So I will use this screen to simulation. Okay, like this. Okay, so we need to create the text for alarm, right? So go to the discrete alarms. Yes, double click here, and then here is the text that we want to show on the screen. Yes, to show the text message, it means that alarm message here. So example, head bearing, high alarm, right? Okay, and I will create the new text for alarm. Go to the text and then create new example alarm text. Okay, and I will use the data type word for this alarm. Okay, and then press OK. Good. And for the trigger bit, if we choose 0, it will start from db1 dot dbdh0, but our point is db1 dot dbdh0.0, right? So I will adjust this one to h. It will start from h. Yes, so it become db1 dot dbdh0.0, the same as this one. Okay, so next we can copy and then paste here. Should be changed to high alarm. Yes, and this one automatically arrange the bits. Okay, so db1 dot dbdh0.1. Okay, and one more for earn bearing high alarm. So earn bearing high alarm. Yes, automatically. One more for earn bearing high alarm. Okay, so we just test 4, and this is the address of the alarms, and this is the alarm message. Yes, for show on the screen. So let's test. I will save, and then I will call the screen by using the button. Yes, I will use a button. Example, go to screen alarm. Okay, something like this. Just example. So if the real practice or everyone have the project should be designed to better than me, because it is just example for this tutorial. Okay, so go to screen alarm. Okay, like this, and then I will go to event and then go to click and choose the activate screen. Yes, here, and choose the screen name for main screen or alarm screen. Okay, so I will choose the alarm screen. Yes, screen number 2, and we need to click back, right, from this screen to another screen. So I will copy this one and go to the screen alarm and paste this one. Okay, and this one should be go to main screen. Okay, go to main screen. Okay, and I will use one more button for activate the alarms. So I need to go to property and then go to column, go to display, and here is the option that we can use the acknowledge alarm or edit the button. Okay, so if I press the checkbox acknowledge button, it happen here. Okay, so let's save the project and then use the simulation, because right now I already online the SIMATIC Manager. Yes, so let simulation. And then go to screen alarm, right? So go to screen alarm. Yes. Okay, I will change this one a little bit. For this one, go to event, press and call activate the screen main, right? Because we need to return to the main screen. And I would like to adjust this one a little bit like this. Okay. And then save the project again. And simulation again. Okay. Like this. Okay, let's test. Go to screen alarm. Go to main screen. Yes. Okay, right now let's see the temperature of bearing and winding around 25 degrees Celsius. So let me hit the thermocouple to show the alarm. Yes. Okay, let's test. Let's see, the temperature will go up. Okay, and let's go to the peg alarm to see the alarm. Right now, here, it occurred the alarm. Yes. Because the temperature is over than set point. Yes. Let's see the alarm message here. Okay. So right now the temperature is lower than set point. We set point 50 degrees Celsius for alarm high. So right now around 43. So okay, 43 something. So I can press the acknowledge for clear the alarm. Yes. Okay. Okay, I will hit again to let's see the earn bearing also here. Okay, so let me hit again, hit the PT100 again. $45, not yet alarm, right? Let me hit again. Okay, alarm occur right now. Okay, because the temperature is over set point, so it appear the alarm. Okay, so if the temperature is lower than the set point here, we can acknowledge. Right now we cannot acknowledge. Let's see here, because it's still alarm. Yes, here around 56, 55. Yeah, it decrease step by step. Okay, so this is a discrete alarm. Actually, we can also create the analog alarm, and I will show and share to everyone in the next video. for how to create the analog alarm. So in this time we already know how to create the screen, how to create the alarm. So if everyone have any project that related to the alarm or show the value of the temperature or voltage or something that convert from analog, yes, to show the real value, everyone can use this step. Okay, so the basic is very important. If everyone would like go to the advance of learning, we can learn from the basic, and the simulation is very important that we can use it to learn from at home or anywhere that we want. So the first one, we need to have the simulation, and especially if everyone have the PLC module is also very important, so we can practice for connect the wiring or some function that we want. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I'm very happy to show and share about how to use the software WinCC Flexible 2008 series page 5 and SIMATIC Manager version 5.6 to create the analog alarms. In the previous video, we already learned about how to use the function FC105 to convert from analog to the real values of the phase A, B, C, sensor 1, 2, 3 of the speed and time bearing and current frequency. Yes, and also we learn about how to create the digital alarm, or we can say discrete alarms, and also test with the real PLC. Okay, so today I will show and share more about how to use the WinCC Flexible again and the PLC S7-300 by software SIMATIC Manager to create the alarms. Yes, it means that analog alarms. And we also learn about how to change the colors if the value is vary. Example, the between of value from 2000 to 3000 RPM, we can change the color, or temperature from 50 degrees Celsius to 60 degrees Celsius, we can change the color. Okay, so first let's go to our software to create the alarms. Okay, so first let's open SIMATIC Manager. Wait a moment for okay, and I will use the existing project that we already learned in the previous video. So let's open the project that it called generator. Yes, here, and then click OK. So we can go to block and open the OB1, and we can online because we already connected the LAN cable from PC to the PLC. Okay, so we can online. Okay, so we need to create the alarms, analog alarms, follow this value, right? So example, we need to limit the set point. Example, the voltage actually 220 volt AC is the normally volt of single phase, right? But this is a generator three phase, so we can limit example 380 volts. So we can use the normal color, and if it up to the 390 volts, so it will change the color and it will show the alarm on the analog alarm also. Okay, so the second, we can open the WinCC Flexible. Yes, and I will use the existing project also for create the new screen or new alarms. Okay, so in the previous video we learned about discrete alarms, right? And we use this alarm for show in the screen. Yes, I will simulate a little bit about the previous video. Yes, okay, here is the data in the previous video. Then we will create the analog alarms, right? Here. Okay, so we need to know about the alarm message that we want to show. Example, the generator. Example, voltage phase A over volt. Okay, or we can say voltage phase A over for alarm message. Okay, and I will use the text here. Let's see. It is the volt phase A, right? So go to trigger text and then choose the voltage A, right? Here. Yes. So double click here, and we can limit the number. Example, normally three phase it will 380 volts something, right? For three phase, So I will limit example 395 volt. It will show the alarm. Phase A is overvolt. Okay. And for phase B, I will create the same. Yes. So I will change this one to phase B. Yes. Okay. And for the limit, okay, I will change this one to phase B. Yeah, for B, it means that phase B. And the value I can set the same, or we can set any number that we want. Example 392 volts. It will show the alarms over volts. So here is the on reaching edge. It means that it trigger for volt 3. I can also use the voltage C is over and alarm. I can change the text to volt C and the number 395 also. Okay, example. It's just example for everyone, easy to understand. But in the real practice on the project, everyone can use another text or another value that everyone would like to show the alarms on the screen. Okay, so it's just example. And one more for the current, right? Right now it's 0 to 150 amp. So example current is over. It just alarm message show on screen, right? Alarm message. Current is over. So I will use the current. And I can limit the number. Example 100. Yes. 100 amp. It will show alarm. Or 120 amp. Yes. We can set any number that we want. Yes. It will show the alarms. And for the frequency, we can set also. Normally around 50 Hertz, right? So frequency is over. Okay, I will choose the text frequency. So the analog alarm is very easy to create. Yes, the same as the digital alarm. Okay, I will choose the frequency text and limit around 50.5. Yes, it will show the frequency is over. Okay, and for the temperature of bearing, yes, or speed, yes. Example generator is over speed by sensor 1. Okay, so I will choose the text of speed number 1 here. Example, normally the generator speed around 3000 before synchronizing, right? So I will choose 315 or 320 RPM. Sorry, 3020 RPM is overspeed. Okay, but we can change this one to be let me check. Okay, right now 3500 rpm. Okay, so no need to change. So this one around 3020 rpm, it will show the alarm per speed. And for sensor number 2 also we can check. Okay, number 2, and select speed number 2 also. And this one we can type 3020 also for overspeed. And for the sensor number 3, yes, we can also choose the speed number 3, yes, and set the limit 3020 also. Okay, and then for temp bearing, right, temperature bearing and binding, we can also set, yes. And then we can use the text, because last video we already learned about digital alarms, yes. So for analog alarms we can use this one, yes. Example, there are two options for temperature of head bearing. Temperature of head bearing is high, yes. So we can use the the temperature of head bearing, and we can limit, example 50 degrees Celsius. And for alarm high we can also limit, example high, and the same text, and we can limit, example 60 degrees Celsius. And also temperature of urn bearing is high, and I will choose the text urn bearing, example 50 degrees Celsius, and we can copy and paste here for high. Okay, the same text, but the value of limit will increase to 60. And one more for temp windings of generator, right? So we can use this one, yes, for temp winding. So example temp winding, yes, is high, so I will choose temp winding and limit around 85 degrees Celsius for high, and high around okay, winding. Winding is high. Winding is high, yes. So the same text, but I will adjust limit to 100 degrees Celsius because it inside the generator coil, so it will hot, yes. So I will increase the range, okay, this automatically. So we can save after we created the text, and we can go to add one more screen for alarm analog, right? For this one is digital alarm. Okay, I can adjust a little bit, and then we can copy and paste, yes, and we will got the new screen, and we can rename the screen for analog alarm. Okay, here. and we can show the alarm automatically. So on this setting, we no need to change anything. We just put here. So if we would like to use the button for clear, we can also use here. Yes, here is disable, here is enable the button for acknowledge the alarms. Yes, and we can save, and we can go to the main screen. Here I will copy one more screen to call the screen of the analog alarms. So copy and paste this one for digital alarm. Digital alarms. Okay, and this one for analog alarms. Okay, and go to the event and then change the screen name to analog alarms right here. Okay, and this one we still keep the same position. Okay, and for this screen we no need to change because we need to go to the main screen, or if everyone would like to change or add one more for button to call the alarm digital, we can also set. Example, this one go to digital alarms right screen. So digital alarms. Okay, and we can go to event and then choose the screen for digital alarm here. Okay, and we can copy and go to the screen alarm and then paste this one to main screen, and this one for analog alarms. Okay, analog alarm, and we can change the event, change this one to analog alarm screen. Okay, so we will got the analog alarms. Okay, when we call the screen. So that's all for this one, and in the next I will show about how to change the color. So simulation first. Okay, then I will call the analog alarms. Okay, this screen. Let's see here, no button for acknowledge the alarms, right? So let me check again. Okay, here. So we can go to property and then go to display and then check the acknowledge button. Okay, and then let simulation again. Okay, I will online the PLC. Yes, go to the analog alarms. Okay, no alarm occur because the temperature or the speed is around 2724 RPM. Yes, let's check here. Yes, so it's not alarm. So I will adjust the milliamp to let the value of this generator is high. Okay, so let's adjust together. Okay, I will adjust the milliamp. Yes, to let the RPM and the temperature. Yes. Okay, I will adjust to maximum, and let's see it has alarm or not. Yes. So right now let's see the alarms. Okay, it has alarm. Generator is over speed. Yes. Frequency is over because it let's see here 60 Hertz is maximum, so it will show the alarm here. Yes, because we already setting. So let me adjust to alarm to be lower than this. Okay, to easy way I will select this option. Yeah, for 220 milliamp. Yeah, easy to adjust. Okay, around 12 milliamps. Okay, and then we can acknowledge the alarm one by one because it lower than setting. Okay, so it not alarms. Okay, so in the next step I will show about how to create the color here. Yes, example 30 around 3000 something, it will show the overspeed and the color is alarm. Yes, so let's go to screen and then go to the main screen. Yes, and go to the speed sensor one. Yes, it's an example, and go to animation. Example, we would like to use the speed one, and for the color, and we will choose this one for integer, and then we can change the color. Example 3022 rpm, it will show the color. Yeah, this color, or we can between also between 3025. Yes, like this, and this one should be example 3030 to 3100. It will change the color. Example red color, and also plus. Yeah, flashing, it means that bling bling bling. Okay, so it will change the color. Let me save and simulation. Okay, so right now it under the 320, right? So the normal color, let's see the green color. So if I adjust the speed to like this, speed 1, right? Let me check again. This one, why not show the color? It over the set point, right? Okay, speed 1, and then this value should be alarms, right? Okay, let's check here and then simulation again. (3,500 RPM, right? So why it not show the alarms? Speed 1, right? Okay. So we can test like this. Yes. Let me delete first and then create again. Example 3000 to 3010. It will change this color, right? Okay. So let's test. Okay, the color is changed. Yes. So if it sorry, this one should be like this. So if the RPM around 3012 to 3050, okay, it will change to red color and then blink also. Okay, so we can choose flashing and then simulation again. One hundred, 350, right? 3,500. Change the color or not? Let's see. Okay, so right now it changed color to be red and blink also. So let me adjust the temperature, sorry, the RPM to less than the setting. Yes, let's see the normal value. Yes, and for another speed sensor we can also set like this. So I will adjust this value a little bit. Example from 3010 RPM to 3025 RPM. It shows this color. After that 3026 to 3500, it will change to this color. And this one also, yeah, the another speed sensor we can also do the same procedure. Yes, okay, do the same procedure. So go here and then choose the speed tool and then choose the integer and go to the value. So here we can choose 3010 until 3025. It will change to this color. Yes, and this until the 3500. It will change to the red color and also blink. Yes, and this one also speed 3, integer also, and the value is between 3000 and 10 rpm to 3025 rpm. It will change to this color, and from this to 500, 3500 will change to the red color and also blink. Yes, and for another temperature or current, we can also set like current integer also. Example from 100 to 120. It will show this color, and from this to the maximum, example 150. Yeah, it will show the red color and also blink. Yes, and then we can simulation, yeah, for test. Okay, so easy to understand about. If we see the touch screen, we can check the color, then we can fix the problem if we use the color for show. Okay, so right now I will adjust the rpm and current of generator to be change the color. Okay, I will adjust. Let's see, the color is changed because it high. Yes, and if I change the current, let's see, the current is also changed. So if I adjust step by step, I can select here. Yes, right here, and can adjust. Okay, can adjust to be lower. Yes. Okay. So we can show the current this color. It means that the high one setting and this one it overspeed. Okay. So this is about how to create the alarms, analog alarms, and change some color that be easy to see on the HMI. If our temperature or RPM or voltage have problem, we can see the color for easy to understand. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my videos. I will reply soon, and I'm also sorry if I have mistake in this video also, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC S7-300 CPU 314C 2PN/DP. Yes, about the analog input. Here is the PLC module that built-in analog input and analog output in this slot, and also has more for digital input and output also. Okay, so I will connect it by using SIMATIC Manager version 5.6, and this is the IP address of my computer that I already manual to IP 192.168.0.253. Yes, and here is the default IP address of PLC 192.168.0.1. Yes, and I will connect by using the RJ45 cable. Yes, connect from the computer to the PN. Yes, PN of the PLC CPU. Yes, and I would like to explain the analog. Yes, actually the analog input and output is already built in. Yes, in this module that include 5 channels of analog input and 2 channels of analog output. Okay, that we can select input and output from here, and here is the address tab. Yes, and when we would like to use the input type, example volt start from 0 to 10 volt or milliamp. Yes, we can select here. I will test and explain when we use the software. Yes, so here is the drawing detail of the channel. Yes, there are 5 channels. Yes, here start from AI channel 0 to AI channel 4. Okay, and the last one of AI is the PT100. Yes, that we can select 2Y or 3Y of the PT100. Yes, I will test for detail. Yes, so for AI channel number 0, yes, it will start the address from the configuration. Yes, here is the default configuration. Start from AIW. Yes, 800. Yeah, until AIW 809. Yes, and for analog output start from AQW. Yes, 800 also, and earn AQW 803. Yes, 803. Yes, so it is the detail. Yes, of the analog signal that we can test for the CPU 314C 2PN/DP. Okay, it include with the CPU. Yes, we no need to add the some cards. Yeah, so let's go to our software to configuration and test with the selection. Yes, okay, so let's go. So I will choose the SIMATIC Manager. Yeah, version 5.6 for configuration and test with this analog module. Yes, So first go to a new project. Yeah, I will create a new folder. Yes, create a new folder. Example test AI of PLC S7-300. Yes, and let's go to new and then choose the browse to find the folder. Yes, that we already created. Example AI. Yes, AI testing, and click OK, and then let insert new object for S7-300 station. Yes, double click hardware configuration, and then let's go to SIMATIC 300 and go to the rack 300 and drag and drop. Yes, and first let add power supply. Yes, so PS example 10 amp. Yes, like this, and let's go to CPU 314, right? C 2pn/dp, right? So go to here and click here. Yes, version 3.3. It is the last version. It means that firmware version. Yes, so drag and drop, and here is the default IP. Yes, if we would like to set, we can set later, configure later. So in this section I will click OK first, and let's see, here is the default address of analog input, digital input, output. Yes, counter. Yeah, it means that high speed counter, and this position control. So in this address we can change also. Yes, but in this section I will use the default address first. Okay, so let's go to configuration, the analog input. Yes, so here is the input. Yes, we can choose both type of input signal. We can use current or we can use voltage. Yeah, if we select voltage, it has two options. Yeah, we can use plus minus 10 volt, or we can use 0 to 10 volt. Yes, and other channel we can use current from 0 to 20 milliamp, or minus plus 20 milliamp, or 4 to 20 milliamp. Yes, actually I use 4 to 20 milliamp. Yes, so I will select two like this, all channel. Yes, and this channel we can select RTD type. Yes, resistance. Example this resistance or this resistance. Yeah, PT100 standard, we can select also. Okay, so it is the input type that we can select. If everyone would like to use voltage, yeah, example the analog input that we use voltage, we can select volt. Yes, or current, we can select current. Okay, so let's click OK and then save the project, and we can download to the PLC. Yes, But before download, please check the communication between our computer with the PLC. Okay, so let's go to network for computer and put the manual. Yes, manual IP address for my computer is already set thing. Yes, actually it show like this. Yeah, so we can set it. Yeah, go here and property and go to ID IP4. Yes, here property, and then we can set 192.168.0.253 example, and we can ping. Yeah, CMD ping 192.168.0.1, right? Here is the PLC address, so we can ping. Yeah, and let's go here and go to the network connection and let diagnostic. Yeah, and test. Yes, it's already, it means that we can connect it to the PLC. Yes, between our computer to the PLC, right? So click OK and then OK again. Yes, and then let's go to our hardware configuration and click download. Yes, select all and click OK. Wait a moment. Yes, for this communication, it take time a little bit. Yes, okay, right now it found one CPU. Yes, that have address 192.168.0.1. Yes, so click view. Yes, and then click here and click download. Yes, so when we click this one, it will confirm stop the CPU. Yes, you see right now the CPU is still running. Yes, the CPU is still running now. If I freeze OK, yes, it will stop the CPU. Yes, and start again. Yes, the CPU will running. Okay, so let's save our project and then let's go to create the block for see the signal of analog, right? So I will open the hardware. Yes, and minimize, and let's go to OP1. Yes, I will choose the ladder. So here we can write move. Yes, so the address is start from 800, right? So I will move PIW 800. Yes, go to MW 0. Yes, let's click F1 to see. Yes, we can write db, yes, dbw. Okay, I will use MW first. So let's download the block and then online. Yes, and then select 2 decimal. Yes, right now it has data, right? So I will select to the milliamp. Yes, yes, right now 4 milliamp I will show. Yes, 4 milliamp the data is show 0. Yes, the data is show 0. So if I adjust the milliamp, yes, I will adjust the milliamp to 8. Yes, you see the data is changed also. 12, yes, 16, yes, 20, yes, is the maximum. And I can decrease, yes, 16, 12, 8, 4 milliamp. It will show 0, right? So if we would like to use other channel, we can write like this. Yes. So move again. So PI W 802, right? And this one MW 4 example. Yes, and we can download, sorry, this one like this. Should be like this. I will add one more network. Yes, and cut this one to here. Yes, and we can comment something, example analog input channel 0, and this is analog input channel 1. Yes, and we can download again. Okay, so right now I already disconnect from this channel. So wait a moment, I will reconnect the cable to this channel. Yes, okay, so right now I already connected the cable to channel number 1. Yes, and let's see the result. You see the terminal that I already connected to here, yes. And right now 8 milliamp. So if I adjust the current to 12, you see the raw data is changed also, yes. And I can adjust, yes. Okay. So there are 5 channels, but the last channel I will show how to use it, yes. Okay, right now I will test with the last channel, yes, of analog input, yes, this channel for PT100, yes. So we can input by ohm, yes. Example 100 ohm, it will show 0 degrees Celsius, yes. So let's go to write the move value, yes. So I will insert one more network, yes, and command analog input channel number 4, right? The last one, PT100, yes. So here is the 4 to 20 milliamp, and this one also 4 to 20 milliamp, right? So I can move. So start from PIW 800, right? So 802, 803, 806, 808, right? So PIW 808. Okay. And example MW20, yes. So save the project and then download, yes. Yes. Okay. So right now I provide 30 degrees, yes. So if I adjust to 0, yeah, this is a 0 degrees Celsius, yes. So if I adjust to 30, yes, 50 degrees Celsius, and this is 100, yes. So it different around 2 degrees Celsius, yeah. So if we would like to use this one to the HMI, we can yes, we can divide by 10, yes. Example, take out this one and divide by 10. It will the same as the temperature of the PT-ROY, okay. So this is the instruction how to configuration the hardware of the CPU S7-300 CPU 314C 2PN/DP by using the Ethernet cable, okay. And we also test with the analog input, yes. And in the next video I will show and share about how to test the analog output, yes, for this one, yes, analog output, yes. So thank you very much for watching my video. If everyone have any question, Please drop comment under my videos. I will reply soon. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to connect the HMI LS brand to the PLC S7-300 CPU 314C2PN/DP. Okay, and in this section I will use two softwares. The first one is SIMATIC Manager version 5.6 for configuration the S7-300 software, and the second one I will use LS software HP Builder version 2 to configure the screen for test and connect with the PLC S7-300. Okay, so I will use LAN cable for connect from my PC to the LAN port of CPU of PLC S7-300, and then connect one more LAN port to the HMI. Okay, and here is the IP address of HMI, and here is the IP address of PLC, and we need to put the IP address of our computer. Okay, so this is the IP address is the same range, so we can ping from our PC to the PLC, and also can ping from PLC to the HMI. Okay, so we can control start and stop the lamp 1 to lamp 4 by using this button by config on the PLC S7-300 software. Okay, so let's go to our software to make the configuration and testing. Yes, so first I would like to use the SIMATIC Manager to create the hardware configuration. Okay, so I will create a new project. Example HMI LS. Let's go to File and then click New, and then browse to find the folder that we already created on desktop. So HMI LS, and this one I can type HMI LS and then click OK. So first we need to insert object of PLC S7-300, example LS HMI, and then we can go to hardware. So wait a moment for open the hardware configuration, and then go to SIMATIC 300, and then go to Rec, add the rail to the project. Okay, and then go to add the power supply. So go to PS. Example, I use this one. So drag and drop. Actually, we need to put the same as the hardware. Yes. But actually, I don't use it. So I just put here. And go to the CPU 300. Right now, we will use the CPU 314C 2PN/DP. The CPU. So drag and drop. So here is the IP address of the PLC S7-300. Yes. And I have one more card for analog input module. SM311. Yes. AIH 12-bit. Okay. So let me insert it. So let's go to SM300, right? And I will add the analog input. Yes. And this one, yes, the part number 7KF02. So drag and drop to the rail. And I need to I need to configure the position, right, of the analog input card. So the first one is PT100. So I will select PT100. The second channel is PT100 also. And channel number 4 until channel number 7, I will use 2Y of current. Sorry, 4Y of current, 4 to 20 milliamp. Yes. And here is the address. Yes. And here is the address of onboard CPU. So if we would like to use the digital input, it will start from I136.0. Yes. And for analog input, it will start from 800. Yes, PIW 800. So let's go to download. Before download, we will set the manual IP address of computer, right? So if now I ping 192.168.0.2 cannot ping, right? Or .0.1 we cannot ping also because we not yet put the manual of IP address of computer. Okay, so let's go to put manual, go to property and go to IP4, and we will put 192.168.0.253 example, and subnet mask 255.255.255.0. So now we can ping again. Okay. So like this, it means that we can ping to the PLC, and one more for HMI. We can ping also for 192.168.0.2. Okay. So we can download the project. for hardware configuration. Okay, let set temporary part. Yes, go to option and then set PC interface, and then go to the PC adapter, right? Right now we use LAN cable. Let's check the hardware here. Which cable that we use here? Intel Pro 1000 MT, right? Active here. Yeah, this one. Yes. And then we can download again. Yes. It detects one CPU 192.168.0.1, and then we can download the hardware configuration. And start again. So right now we already create the hardware configuration. So we need to create the program for start and stop to control the lamp 1 until lamp 4, right? So let's go to OB1 and then choose the another language that we want. For me, I will use ladder. So here is the lamp 1, so we can comment. So I will write stop for lamp 1, start for lamp 1, and lamp 1 output. And I will hold the signal. Okay. So we can use the M 0.0 and we can comment. Example, PB stop lamp 1. Okay. And here is the address, example M 0.1. Then we can edit the symbol. PB start lamp 2. And here is the output. So if we would like to control the lamp, let's go to see the hardware configuration again. Here is the digital output. So it will start from Q136.0. Yes. So Q136.0. And then we can edit the symbol. Example lamp 1 stator. Okay. And this one should be hold the signal, right? So lamp 1 stator also. And then I will insert one more network for lamp 2, lamp 2, lamp 3, and lamp 4. So insert one more network, and I can copy the command here. And we can use NC, NO, coil, and hold the signal. Yes. And here we can use M 0.2, right? Because here we already used the M 0.1 and M 0.0. So it should be PB stop LAM2, and this one should be M 0.3. So PB start LAM2. Okay, and this one should be Q136.1. LAM2 stator. Yes, and this one should be LAM2 stator also. And I will insert one more network for LAM3. So use the same instruction. Sorry. Okay, this one should be M 0.3. PB stop LAM 3. M 0.4, M 0.5, right? So PB start LAM 4. Sorry, LAM 3. And this one should be a Q136.2, right? And we can edit. LAM3 status. Okay, and this one should be LAM3 status also. And the last one for LAM4. So an O and C coil and hold the signal, right? So this one should be M 0.6. PB stop, sorry, PB stop LAM4 M 0.7. PB start LAM4, and this one should be Q136.3, right? And we can edit symbol LAM4 stator. And this one we can copy. Yes, and then we can save the project and download the logic to the PLC, and we can online. Okay, so we need to create the project of HP30 control from the PLC HMI, right? So let's go. First, let's go to open the HP Builder version 2 and create a new project and choose the series of the HMI. For me right now I will use HP series and choose the HP 300 TTA, yeah, to match with the hardware of model of HMI. And here is the controller. It should be select the correct controller. So on marker I will use Siemens AG because right now we use the Siemens. Actually we can connect to another brand that we want. Example Yokogawa, Omron Corporation, Mitsubishi, LS, IS, and another brands that we want. Okay, so right now I will use Siemens AG and choose the protocol, product S7 300 400 Ethernet because right now I use LAN cable, and go to the communication setting and we will choose the communication to correct the function. So detail here is the IP address of PLC. Yes. So 192.168.0.1. Here is the IP address of PLC here. So click OK and then OK again. So we will got screen like this. So first I can go to the screen property and change the color background to be this color. Yes. And we need to create the button. Yeah. For start the lamp one, right? So go to bit switch. So we need to create the stop button, right? Example, this is a device address. So it will start from M0.0, right? For stop button of lamp 1. So here we can choose M0.0. Yes. Here M0.0. So we need to choose M0.0 and then click OK. And I will use the momentary because when freeze it will on, release it will off. Okay. So I will choose momentary. And if the display like this, we are difficult to see, right? So we need to change the button background. So we can go here and then go to a library. We have many library that we can use. Example, we can use this button. Yes. And then we can change the color, right? Can change the color. For stop button, I will use red color like this. Okay. And we can copy. Yes. For start button. So copy and then paste. Okay, we can align. So here we can go to property or we can double click. Yes. and here is the button start, right? So we need to put the address with correct address. So M0.1. Here we can type M0.1 and momentary also, right? And for the display, I will change this color, or we can use the blue color here. Okay. So we finish the lamp one, so we can put the text. Okay, example start. And this one should be stop. For lamp 1, right? And then we can copy to another lamp 2, sorry. This is for lamp 2 and this is for lamp 3. Actually we can adjust to be smaller than this. Let me adjust a little bit. Okay, like this. Or we can copy to be the same, right? Okay. Please Control and Shift and then drag and drop. Can also copy. This one M0.1, right? And the display should be blue color. Adjust to be aligned with the button. Okay, like this. And then we can drag and drop for copy. Not enough, right? So we can align a little bit. Okay, for lamp 2. This is just example. Actually, we can design to be good looking. Yes. So we can align. Okay. Okay, test like this. And then we need to change the address, right? This one should be 0.2, M0.3, M0.4, M0.5, M0.6, and M0.7. Okay. And this one for lamp 1, so we can mark. This is for lamp 1, this is for lamp 2, this is for lamp 3, and this is for lamp 4. So I will change this one to lamp 2, this one for lamp 3, this one for lamp 4. Okay, and we need to create the lamp stator, right? So let's go to bit lamp. Okay, like this, and we need to put the address, right? So it will start from Q 136.0. So let's go to Q 136.0. Okay, and for display we can choose here. The stator on, it should be green, right? So I will choose green, and when off it will show red, right? So when it off, it will show the red color, right? And it on, it will show the green color. Yes, so we can drag and drop to here. Okay, and we can copy this one. We can use the lamp one here. Lamp 1 status, right? We can adjust the size a little bit. Okay. Then we can copy, yes, for lamp 2, lamp 3, and lamp 4. Yes, and change this one to lamp 2. Lamp 3, lamp 4, and we need to change the address, right? For the lamp 2, it should be Q316.1. Yes, so 316.1, 316.2, 316.4, and we can adjust like this, and we can copy the text to add the title. Example, connect PLC HMI HP30 to PLC S7-300. Okay. CPU 314C 2PN/DP. Okay, and we will adjust the font size a little bit. Okay, good. I will change to be this color. The red color, right? Okay. So we can download the project of HP Builder to the HMI, right? Because right now we already connect it, yeah, from our PC to the PLC, yes. Sorry, to the HMI. So we can download this project, yes. To download this project, we can click download, and we can choose the setting, yeah. Right now we use the Ethernet module, right? Ethernet port. So we can click the Ethernet and make sure that we put the IP address, yeah, correct the IP address, and then choose the correct hardware adapter, yes, here of computer, and we can scan the HGT panel, yeah. Here is the IP address of HMI, yes, and then we can click OK again, and we can click download, and project will be download, yes. So we need to save the screen, right? So let's go to desktop and then go to the HMI LS project, right? We can put project 1, and then click save, and it will download the project to the HMI. Let's see right now downloading the project. Okay, finish, and the screen will start up. Okay, finish successfully for downloading. So let's go to logic, our logic, and we can freeze to see the status. So if I push the button start, yes, yes. Let's see, the lamp 1 is turned on, and the PLC is turned on also, yes, the status. So I will connect power to the output of PLC. Okay, so right now I already connected the cable power to the module of PLC S7-300. So let's test again. Okay, right now let's see the output is turned on. Yes. So if I push button start for lamp number 2, it on also. Number 3 on also. Number 4 on also. Okay. So we can stop. Example, I stop lamp number 3. Yes. Number 2, number 4, and number 1. Yes. Start again. Yes. So we can start and stop and show the condition of PLC. Yes. So if we would like to control, we can connect the cable from output to control the relay or some electrical devices. So we can control, yes, from the HMI. Okay. So this is just instruction about how to connect the HMI LS brand to PLC S7-300 CPU 314C 2PN/DP via LAN cable. Okay. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to read data from encoder by using PLC S7-300 and HMI HP30 with LF brand. Yes. And I will use the software SIMATIC Manager and software HP Builder version 2.0 to configure the project of HMI and download the project to the HMI LS. Okay. And I will show step by step about how to wiring and how to create the block to read the data from encoder by using this input. Okay. So first I would like to explain a little bit about how to wiring the connection of encoder to the PLC input, because it's very important. If we cannot wiring the connection, it means that we cannot read the data from encoder. Okay. And I will use the LAN cable connect from my PC to the PLC, and then another port from the PLC I will connect to the HMI. Okay. And here's the encoder, incremental encoder, that I already connected the power cable and signal cable to the PLC S7-300 input. Yes. So let's go to see the drawing. Okay, here is the drawing detail that I already draw for easy to understand. So for here is the CPU 314C 2PN/DP, and here is the Profinet port or Ethernet port, and here is the Profibus port. Here is the switch on and off for turn on and off the CPU, and here is the H1 of analog module and also not used right now. For terminal H2, right now I will use for connect from encoder, and here is the encoder, just example. So I will use 4 cables, 4 cores. Yes, one core for supply, yes, to encoder 24 voltage, and here is the minus, and here is the plus, yeah, that connect supply for encoder, and here is the signal from encoder that will connect to the terminal number 2 of H2 terminal, and for terminal number 3 I will connect one more because we can use for reverse and forward. It means that increase or decrease value, so we need two cores of cable from encoder. Okay, for positive voltage I will connect to terminal number 1 of this card, and for terminal number 20 I will connect the minus, yes, of 24 voltage. Okay, so please follow my drawing, otherwise we cannot read the data from encoder. Okay, so when we increase the encoder, the input will turn on, yes. So this is just summarize about how to wiring connection of encoder, yes. So let's go to our software to create the new project of SIMATIC Manager and HP Builder to download to the PLC S7-300 and HMI to read the data from encoder. Okay, so let's go. So first I will create the new project of PLC S7-300. So right click and then create a new folder, example encoder, HMI LS encoder. So open SIMATIC Manager, and then go to create the new project, file, new project, and browse to find the folder that we already created. Okay, HMI LS encoder, and here is the project name, example LS encoder, and then I will insert the object S7-300 station. Okay, and then I will create the rail, yeah, insert the rail. Let's go to the rack 300 and then create the rail, drag and drop here, and then go to the power supply, yes, go to PS 300, and then I'm going to add the CPU, yes. Right now we use CPU 314C 2PN/DP, this version, and here is the IP address of PLC 192.168.0.1 and subnet mask 255.255.255.0. Then click OK first, and it has one more for one more card analog, yes, that I already insert because right now we don't use it, but I just insert it. for analog input. So I will create one more. Otherwise, if we download to the CPU, it will fall because the hardware configuration must be matched with the software. Okay. So I will use SM300 AI, and here is the model number. And I will revise the input. The first one is RTD. The second one is RTD also. And the third channel is 4Y current for 220 milliamp. Yes. And we need to use the counter right here. Here is a counter. So to enable the counter, first let's go to channel. Totally we have 4 channels, but right now I use only one channel, so I will use channel number 0, and we need to enable this one. Yes, count continuously. Yes, and here is the address. Start from 816. Yes, and the next step I will explain about how to calculate to the convert to hexadecimal. Yes, so click OK and then save the project. Yes, and we need to download the hardware configuration to the PLC, right? So first we need to manual the IP address of computer. So let's go to put the manual. Right now the PLC IP address, PLC IP address 192.168.0.1, right? So we will put the IP address of computer to be matched with the rank of the PLC. Otherwise, we cannot ping. We cannot connect from our PC to the PLC, right? So I will put 192.168.0.253. So 192.168.0.253, and subnet mask is the same, 255.255.255.0. Okay, and we need to turn off the Windows firewall also, otherwise we cannot connect. So right now we can use command prompt to ping 192.168.0.1. Yes. So right now we can ping from our PC to the PLC. So we will download. Okay. So right now we already download complete and successfully. So we need to create the block. Yes. For read the data from encoder, right? I will use the ladder language. Okay. And I will use the library Yes, standard library block. Let's go to library and go to the standard library. And go to the system, yes, and find the SFB47 here. SFB47, it is the count continuously. So drag and drop to our network. I will zoom a little bit. Okay, so this is we can comment from encoder and show value on HMI LS HP30. Okay, so I will use DB1. Yes, if we put DB1 here, it will create automatically here. Yes, and then we need to put the channel number. Yes, so here channel number 0, right? Because right now I just put the channel number 0. It means that I just enable for channel number 0 of the count continuously. Yes, so here I will put 0 because we use channel number 0. Totally we have 4 channels, right? So I will use channel number 0 first. And for LADDR, yes, we can use the address but convert to hexadecimal. Okay, so for the address here, it will start from 816, right? So 816, so we can use the calculator. So 816 convert to hexadecimal, it should be 330. Okay, so here we can put 330. So hexadecimal 330, and we need to show the value of encoder, right? So here count value, I will put another memory, example MD 0. Yes, so we can save the project and then download to the HMI, sorry, to the PLC, and we need to download all blocks also. Okay, and then open again, and we can online to see. Okay, and I will use the hand by increase the encoder and discrete. Let's see the signal. Right now I will increase. Okay, let me increase the encoder. Right, it's not working, right? Because of gate we not yet enabled. Okay, so I will enable the gate switch here, otherwise it will not working, right? So we need to put the gate switch, yes, with gate here. Example, I will put M 10.0 and then download again. Okay, and then I will turn on the M 10.0. Yes, I will turn on, so I will put true and then let's test again. Okay, let me rotate the encoder again. Let's see the value is decrease and increase. Yes. Follow the rotation. Okay. Let's see the input is turned on. Yes. And turn off. So we need to show the value here on HMI, right? So let's go to I will cancel this one first. So let's go to create the project of HMI and then download to the HMI to see the status. Yeah. So first open HP Builder version 2 and then create a new project and let select the serial number of HP series. Yeah. So right now I use HP 30 TTA and here is the marker. We can use another brand of controller that we want. So right now I will use Siemens AG because we use PLC 300 and I will use 300 and 400 by Ethernet and go to communication, and here is the protocol. Yeah, so Ethernet, and here is the PLC IP address. So 192.168.0.1. Yes, so correct. So click OK, and then I will change this color to be background to this color. Okay, like this. And then we can read encoder by using the numeric display, right? So click here and then use the and here is the address of encoder of the value of output encoder. So here we have only IW, QW, TW, CW, MW, and DB, right? So we need to convert here to MW, but this one. So let me modify. Actually here we can use the move. I will move this one to MW. Example MW10. Yes. Save the project and then download to the PLC again. Yes. So here we can use MW10. Click OK. And for the format, we can follow this one, 16-bit. And here is the numeric. Yeah. So we can use unsigned decimal. And here is the number of display. It means that this one. Yes. If I increase, it has like this. Okay. The 1 digit. So normally I can use only 6 or 5 digit. And here is the decimal. Yes. So we can adjust the display to be good looking. Example, this one center, font, yeah. Font size, Tacoma, example 26. Yeah, should be like this. So I will comment like this. Example, I will use text. Yes. We can adjust. Yes. And I will adjust the font size to be 28. Okay, or not. It's so big, right? Okay, I will decrease to 24. Okay. Then this one link with HMI, LS HMI, HP 30 TTA. Okay. I will use yellow color. Actually, everyone can adjust the screen, yeah, that we want. And I need to use the one more button, yeah, one more switch for enable the switch gate, right? So let me choose the one more switch. Okay, switch bit. So I'm 10.0. Yeah. So we need to put the address. So M 10.0. Yes. And I will use the alternate because we need to click and then it will hold the signal. Go to display, go to library. I will use the library, go to all. Then I will use this button. I will change the format, yes. Like this. And we can adjust, yes. Okay. And then we need to download this project to the HMI, right? So let me check the HMI 192.168.0.2. Yes. So we can ping, and then we can save the project first. I will save to desktop and then choose the this one, encoder. Then I will download this project to the HMI. Click download and then go to setting, and here is the setting that we will choose the correct setting. So 192.168.0.2 is the IP address of HMI, and here is the network adapter of my PC. So click OK and then click download. So wait a moment for downloading the project to the HMI. Let's see now, downloading. Yes, finish. HMI will automatically reboot after finish downloading. Right now, starting up. Yes, open screen. Okay. So right now, let's see the value of encoder is 65. Yes. Let's online the PLC. Yes. 65 also. So if I adjust the encoder, let me adjust the encoder. Yes. The value is not increase and decrease, right? Because we not yet enable the switch gate. So if I enable the switch gate, yes, then adjust again. Let me check the switch gate on or not. It's not on, right? So let me check again here. M10.0 momentary. Okay, I will change to this one and then download again. Okay. And we will test again. It's not on, right? Let me check. M10.0. That's correct. Let me download the block, all block again. I will change this one to M100.0. Yes. And then download again. Because here we use MW10. Yes. So let me adjust this one to M100.0. And then save and then download again. And we will test after we finish downloading the project of HMI to the HMI. Starting the HMI. Okay, finish and go to online and then check again. Okay, the switch gate right now 1, right? So we can increase the HMI. So I will increase. Yeah. Let's see the value is increase, start increase and decrease. Follow our adjustment of encoder. Yes. Okay. Yes. Decrease. So here is just example about how to connect the HMI LS to PLC S7-300 and read the data from encoder. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use SIMATIC Manager and WinCC Flexible software to control the motor step by step by using the timer. Okay. In the previous video, we already learned about how to use the timer, how to set and how to show the status of timer on HMI. And we also tested with the real HMI also. And we learn about how to transfer the project from the WinCC Flexible to the real HMI and how to download the project to the PLC also. Okay. So today we will continue to start the motor 1 to motor number 4 by using the timer. Okay. So the concept is when I push the start button, the motor will turn on, and then after we have the timer, then we can set the timer for start motor number 2 and number 3 and number 4. Okay. Then if we would like to stop, we can stop button and the motor will stop step by step also. Okay. And then we will create the existing project. Yeah, I will use the existing project that we already learned in the previous video to create the one more screen for control the motors. Okay, and then we will transfer the project on WinCC to the real HMI also. Okay, so let's go. So first open SIMATIC Manager. Then I will use the existing project. Yes. Okay, I will delete the network number 2 first, because I need to create the step-by-step of motor number 1 until number 2 until number 4, right? So this one should be motor, or we can write like this. We can cut this one here. Okay, right? So I will start the motor. Okay, I will insert one more. Sorry, and C for stop, right? So we can use M 0.1. Should be stop motor step by step, right? Okay. So this one should be start motor step by step. Okay. And then I will cut the motor one here. Or we can keep here. Then I will hold the signal, right? I will hold the signal by motor number 1. Okay. So when motor number 1 is turned on, then I will set the timer and control the motor number 2, right? So this one should be Q136.1. Okay, motor number 2. And when the motor number 2 is running, yes, when motor number 2 is running, I will use one more timer for delay on also. Example T1. Then I will set the timer also, right? Example MW 54. Yes. And then it will start motor number 3, right? So Q136.2, and this should be motor 3 status. Yes. After that, I will use the command from motor number 3 to start motor number 4. Then I will use timer one more, T2. So MW 58, and this one should be motor number 4, right? So Q136.3, motor 4 status. Okay. So sequence start we already created. So this one should be a motor 1, motor 2, motor 3, and motor 4, right? Then we can save the project. So we need to create the button stop, right? So if we use the button stop here, when we stop, it will stop immediately for all motor, right? But I need to stop the motor number 3 first. Okay, so we can create one more program. This should be a start sequence. Yes, and this one should be stop sequence. Yes, so when I push stop, I will use NO also for stop. Okay, I need to stop the motor number 4 first, right? So when I push stop, I will use the memory. Example M 0.2. It is the stop command sequence, right? So I will interlock with the start button. Oh, this one should be Okay, start button here. Okay, then the stop sequence should be hold the signal also, right? Okay, and then this one should be stop sequence command and hold the signal also, right? After that, I will use the timer. Yes. Example. Sorry. Insert one more network, right? And this is for stop motor for command. So when this one stop, this one on, it will stop the motor, right? So here we can use NC to stop motor. Example M0.2. Okay, stop motor number 4. Okay, then we will delay stop motor number 3, right? So we can insert one more timer. So when motor number 4, yes, is stop. Sorry, here. And command stop is turned on. Then the T4, right? T0, T1, T2, T3. Okay. T3 will action. And then here we can use MW60, yeah, example 62, yes. Then we'll stop, yeah, M0.3, right? It is command stop motor number 3. Command stop motor 3. Then we can copy and then use the NC for stop motor number 3 here. Okay. And we will insert one more network for command stop motor number 2. Okay. So if motor number 2 and number 3 is stop, motor number 2 and motor number 4 and number 3 is stop, then I will use one more timer and with command stop. So T4 MW T6, and then I will use the memory M0.4 for stop. So command stop motor 2. Okay, so we can copy and stop the motor number 2 right here. You can use NC. And the last one, we can copy this one, yes, this one, and one more for motor number 2, right? This one. Motor number 3, this one. Motor number 2, this one, right? This one. And then end with the stop command, right? This one. So we can copy and then paste. And I will use one more timer on, yeah, for T5 and MW 70, and then I will use one more memory M0.5 for stop motor number 1, right? So command stop motor 1, then I will stop motor number 1 here, okay? And then we no need to use this one, yes. But in this case, we need to put the emergency switch, otherwise it be not safety, because we cannot use stop immediately, yes. So we need to add more for emergency stuff. Example, emergency stop, I will use M0.6. Okay, M0.6 for emergency stuff. If push one switch, emergency stop, it will stop all the motor, right? Okay. So emergency stop switch. Okay. And then I will copy to all the motor. Okay. That's all. So we can download the project to the PLC. Okay. Motor 4 running, right? Okay, so we can push stop, right? Stop sequence here, M0.0. This one should be M, okay? M0.0 right now is turned on, right? Start is turned on. Okay, so we can push stop, right? Let me check here. This one should be push button. Oh, okay, it linked from the HMI. Let me adjust the HMI. Okay, so right now we need to create the HMI for control for set the timer and show the timer on the HMI. Okay, so let's go to WinCC Flexible and then go to the existing project that we already learned in the previous video. And then I will copy and paste one more screen, motor, screen motors, yeah, double click, and then we can design the screen that we want. I will delete some button because we need to use with another button, right, for start and stop sequence. So I will delete some part of existing project. Okay, like this. Then here I still keep because we need to call the screen also. Okay, so this one should be control motor step by step using timer. Okay, we can design like this. We can adjust the screen to be good looking. Yes, follow our design. Yeah, for everyone here. So I will adjust the screen a little bit because we use for motor, so I need to adjust this one to be smaller than a bit. This one I should be delete first, then like this. For motor number 1 I will use the take. So motor number 1, I will use this color. Oh, I need to change the color of screen to be original, right? Back to original, maybe this color. Yes, then we can see this one, and I will copy for motor number 2, number 3 and number 4, and here I keep first because we need to use the set the timer. Yes, so this one should be motor number 2. I will keep here. Yes, motor number 2, and one more for motor number 3, and one more for motor number 4. Yes, motor number 4 here. Okay, So for motor number 1 until motor number 2 until number 4, we need to set the timer, right, for start and stop. So here I will adjust the text a little bit to be 12. Okay, like this. So we need to choose the setting, right, for motor. Okay, setting like this. It has time start and time stop, right? So for motor number 1, no need to set the time start, because when we push start, it will start directly, right? So another motor I will copy for time start and time stop. Example, this is motor number 2, motor number 3. Actually, we can adjust a bit for this one to put the timer. Should be like this. Okay, and this one, and this one can use like this. And then we can put the timer here. Okay, can put timer here. Then we can put timer here. Okay, and the last one, we can put timer here. Okay, so this one we can use like this, because it has time stop and time start, right? For motor number 1, we don't use the time start, so I delete 1. We just put only time stop. I will use the yellow color or another color that we want, this color, and adjust the font size a little bit to be 12. Yeah, time stop, I will change color because this color is not good for looking. Okay, I will use red color. For motor number 2, we have both time stop and time start, right? So I will adjust this one for time stop and adjust this one for time start. So this one for time start. This one for time stop. Okay, and then we can adjust this one also. This one should be have only time start, right? So I will delete one. Okay, but this one should be has two, one for time start and one for time stop. Okay, this is just example, so everyone can design the screen style that we want. Okay, time start, time stop. Okay, then we need to create the text, right? We save the project and then create the text for set the time stop and time start for this motor. Maybe I will use the yellow color, is easy to see. Yes, this color, and then save the project again. And let's go to create the text. Go to text. Okay, this one should be a start sequence, right? So I will put start. Okay, this one should be stop. And one more for emergency, right? Emergency stop. M0.6, right? So I will use boolean and will use M0.6. This one should be command emergency stop speed. Okay. And let's create step by step from the top. So start, we already created. So command stop motor number 1 here. Yes, we need to create only start and stop in an emergency, right? Okay, and for motor number 2, number 3 and number 4 we need to create also. Okay, so for motor number 2 we already create number 1 also, so here we can copy and paste for motor number 3. Then this one should be 136.2, right? Motor number 3 stator, and copy one more and paste for motor number 4, 136.4, right? Motor number 4 status. Let's check again. Motor number 4, right? 136.3. Okay, 136.3. For start stop emergency we already created. Yes, so we can go to our screen motor, right? So we can create the button for start and stop sequence and emergency stop. If have emergency we can push to stop all the motor, right? So start, I will use this color. Sorry, this one should be black. This one should be red, and then I will adjust little bit to be like this, and then I can copy for button stop. So start button should be blue color, right? Or green color, yes, like this. And one more, for emergency, I can use the emergency stop. Yes. Then I will adjust. Okay, like this. Then we can save the project again, and then configure the button for start and stop and timer for set, right? So we need to create more for text, set the timer, right? So let's go to text. Okay, for start motor number 2, we can use the MW50. We already configure MW50 here. Yes, this one should be a start time M2, right? And then we can copy and then paste. Start time for M3, '54, right? Start time for motor 3, and this one should be start time for motor 2. Yes. Then this one should be start time M4. Yes. And this one should be start time for motor 4. Okay. Then we need to create stop time also, right? Stop time, go to stop sequence and then stop time for motor number 4. Here. Stop time for motor number 3. Yes. MW62. So this one should be stop time for stop time M3 64. Stop time for motor 4. Stop time for motor number 3. Stop time for motor 3. Time sorry, this one should be a stop timer M4. Stop timer M3. stop timer M4, sorry, M2, and the address should be put with the correct address, otherwise we cannot control, right? 62, 66, stop time for motor number 4, 62, right? So this one should be 62, 66, and 60 and 70, right? And the last one, stop time for motor number 1, command, stop time for motor number 1 command, stop time for motor number 4, number 3, number 2, and one more for number 1, right? So stop time number 4 here, number 3 here, number 2 here, and number 1 here, right? It starts from T3, 62, 66, and 70, right? 62, 66, and 70. So this one should be stop time motor number 3, number 1, number 2, and number 3, right? Because we have stop time only 3 motor and start time only 3 motor also, okay? So that's correct. So this one should be stop time for motor 1. This one stop time for motor 2. This one stop time for motor 3. Okay. So we can go to our screen and then configure the timer. Stop time for motor number 1, right? So we can go to the general input, right? Because we need to input. And then we can go to the text for stop time motor number 1, right? Stop time motor number 1 here. And this one start time, right? For motor number 2. So start time for motor number 2 here. Stop time for motor number 2 here. And then start time for motor number 3 here. Stop time for motor number 3 here. And then start time for motor number 4, right? Okay. That's all. Then we can configure the motor status. This one motor status number 1, right? So go to animation and then choose motor 1. It is correct because I just copy from the previous screen. So for motor number 2, we can change this one to motor number 2 status. This one change to motor number 3. And this one we can change to motor number 4. And then we need to configure the button start, stop, and emergency switch, right? So I will change this one to be yellow, easy to understand. Or I will change this one to be this color. Yes. Okay, then we can configure the button. Let's go to event and then go to freeze, because we need to freeze and release, right, for start and stop. So I will set take. So set take for start, right? And when I release, I will reset take, and then I will reset the take start also, right? Because when freeze and release, it should be off. Freeze on, release off. Okay. For stop, also I can set take and then set take stop, right here. And for release, I will reset take release, take stop. And then for emergency, I will use click and then use the invert bit stop. Sorry, emergency stop. Okay. So that's all. Then we can save the project and can call the screen, right? Example, if we would like to go to screen main, so we need to call the screen. I will call from the timer on. So this one should be called screen motors. Okay, and then change this one to activate screen motors here. Okay, then we can simulation again to make sure our screen is correct or not before we download to the real HMI. So I will call screen motor. Yes. Then I will download again because I just adjust the command. Yeah. So example, I will set the timer, this one to stop, right? Start. Example, I set 10 seconds for start and stop also 10 seconds. Okay, 10 seconds off. Yes. So I need to stop first. Emergency to release all, right? Timer will action and then motor number 2 will start. Yes. After that, we will wait the timer for start motor number 3. Okay, number 3 is starting. And after that, 10 seconds, the motor number 4 is start also. Okay. Okay. So right now, we can push the stop for stop sequence, right? So motor number 4 will stop. So we need to see the condition of timer when count also, right? So we need to add more for take for monitor the timer condition. Okay, stop motor number 2, and then it will stop the motor number 1 also after 10 seconds. Then we can start again. Yes. So motor number 1 is start, and then wait motor number 2 start also. Motor number 3. So we need to see the condition when timer count, right? So we need to create one more for stop sequence and start sequence timer. Okay. If we have emergency, we can push stop emergency, then all motor is stopped. Okay, and don't forget release, otherwise we cannot start again. Yes. So right now let's go to add more for sequence start. Yeah. Example, start motor number 2. So we need to show the status of timer also. So for timer number 0, we already created here. So I just change this one to T0. It means that motor timer start M2 stator. Yeah. For T1 should be timer start M3 status, and we can copy for we can paste for motor number 4 start stator, and this one should be a T3, right? Start motor number 4 is T2. So this one timer M4 start stator, and this one should be can copy from this one and change this one to motor number 2, right? M2, and this one M2, this one should be M3. Okay, and we need to create the stator of stop command also, right? Stop sequence T3 for command number 3. Yeah. So timer stop, change this one to stop M3 stator. Okay, T3 timer stop for motor M3 motor 3 status. Then we can copy and paste, change to M2, change this one to M2 and copy one more for M1, can copy and paste for M1. This should be a T4, right? Let's check to make sure. Should be T4 and T5, right? So this one T4 and this one T5. Okay, this one should be motor 1. Then we can save the project and go to our screen again, and then insert one more. This should be status, right? So this one timer status, so we can stop timer 1 stator. stop motor M1 stator, right? T5, and we need to use the output because we need to show the value, right? This one I can adjust to be like this. Yes, to put one more for stator. So we can drag and drop for copy, yes, and put the text that we already created for motor 2. It is the output also, right? So motor 2 stator. Actually, we should have start and stop, right? Okay, right now I will use the start first. Start motor M2. Yes. T0, start motor M2. And we need to add one more for stop, right? So I will adjust a little bit more for this. So this one for stop. A bit. Okay, for stop. Motor M2. So let's check the stop for motor M2. Here, stop motor M2 stator. And for motor M3 also, we can adjust this one to the top and then insert for start, right? This one should be output. And then for start motor M3 stator. And one more for stop stator, right? Stop motor M3 stator. And for motor M4 we have only start and stator, right? So we can copy. Okay, drag and drop for copy. This one should be output. And stop. Stop M4. Okay, start M4, right? Okay. So we can adjust this a bit. Okay, like this. So motor M3 and M2 is the take is so much, so we can adjust like this. Then save. And we can simulation again before download to the real HMI. So I will call screen M, yes. And for setting start, we can set example 10 seconds. 10 seconds, yes. This one should be 10 seconds. 10 seconds. Or everyone can adjust the timer, yes, that we want. So let me start again. So we will start from the motor number 1. Yes, here. So if I start, oh, it's not correct, right? T2 is on, yes, the T2 is on, yes, correct, it turned on, and then the T3 is turned on, so wait 10 seconds, okay, correct, then the T4, yes, it's start count to start the motor number 4, right? Okay, start. So if I would like to stop, I will stop this one first, right? Then it will count for stop motor number 3. Okay. Stop motor number 2. And stop motor number 1. Okay, the last one. Okay, stop. If we would like to adjust the sequence start to be example, I will increase this one to 15 sec, and this one should be 9 sec, and this one should be 5 sec. Okay, faster, 6 sec, 6 also, and this one should be 4. Yes, so we can start again. It's faster than before because we adjust the timers to be shorter than, yes. So sequence start and stop is very fast. Okay, and then I can stop. Okay, stop. Stop again. And the motor number 1 is will stop also, right? Okay, then we will prepare download to our real HMI. So let me exit the simulation and then go to save the project and then go to download, but don't forget click the transfer. Yes, don't forget click the transfer. So right now I already click the transfer, so we can transfer. And then click yes to confirm the transfer file. Yes, transferring the file. Then wait for start up. So I will call the motor. Yes. So we can set the timer. Example, I set 6. Okay. 6 also. Yes, 6 seconds. So we can start. Okay. Motor is running. Start motor number 2. Start motor number 3. And start motor number 4. Yes. And the output is on also. Let's see. So we can connect to start the motor. Yes, to the real motor. So if I would like to stop, I can stop motor number 4. And then timer stop motor number 3. Stop step by step. Yes. Stop motor number 1. And we can freeze emergency to stop. Let it start again. Okay. If we have problem, we can push emergency stop. We can stop all the motor. Yes. And restart again. So this is just example about how to create the start and stop sequence of 4 motors that we can create start and stop from the HMI also. Okay. So for the logic that we create, we can choose another way to create the logic that we want. For me, it's just example, so I create like this for example to show to everyone. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the SIMATIC Manager and WinCC Flexible 2008 software to set and show the timer on HMI by using PLC S7-300 CPU 314C2PN/DP that include 2 Profinet ports, yes, and one port I will connect to my PC and another port I will connect to the HMI. Okay, and here is the IP address of PLC 192.168.0.1, and here is the IP address of my PC 192.168.0.253, and here is the IP address of HMI 192.168.0.2. okay, and here just example, so we can use the timer. Example, timer on, we can set the delay for setting. We can set from the HMI, and it also can show the time also when we click the enable of timer. Okay. In this section, I will use 2 types of timer. One type is timer on delay, and another type for timer off delay. Okay, and we will design 2 screens like this to show for everyone. Okay, so let's go with me step by step. Okay, first let's go to open SIMATIC Manager software, and I will create a new folder. Example, timer. Okay, and create a new project. Example, timer show. Browse the folder that we already created on desktop. Click OK. And then I will insert the object SIMATIC 300 station. Okay, timer on off. And I will create the hardware configuration. So first let's go to SIMATIC 300 and go to the rack 300 and drag and drop the rack, yes, to the project, and then we can add power supply, yes. Example, I will do this one. So in this step, everyone can choose the power supply to match with our hardware. Okay, this is just example. And next step, we will create the CPU. So right now I will use CPU 314C 2PN/DP. Yes. Okay, and here is the IP address. Yeah, the same my slide that I already show here. Yes. And then let's click OK, and it will arrange the I/O address for us because it is built-in I/O for DI, DO, AI, and AO, and also counter, yeah, high-speed counter and position control also. Okay, so it very important for the CPU. We can include on the CPU with the many I/O that we can use. Yes. Okay, so let's save our project, and then we can download the hardware configuration to the PLC, right? So first I will connect the LAN cap wall from my PC to the PLC. Okay, and then go to put the manual IP address of computer, right? Because right now it we ping to PLC example 192.168.0.1. We cannot ping, right? So we need to put the manual IP address here, 192.168.0.253. It is the computer IP address, the same my slide that I already show. Yes. So after that we can ping again. Okay, so we can communication between our PC to the PLC S7-300. Okay, so we can go to download. Okay, and stop the CPU because we download the hardware configuration. Okay, and then we need to create the logic, right, to follow the timer instruction that I already show here. Yeah, example timer on, we can set the timer and we can show the timer status on HMI. Yes, so we can go to the ladder. Okay, block, and then go to OB1, and I will use ladder, easy to understand. Yes, easy to write for ladder. So here example timer on, link to HMI. Okay, so let's go to timer, and then I will use the on delay. Yes, and here I need to use the one button or one switch to enable the timer, right? So let's go to this button. Example, I use M0.0. Okay, and let edit. So example timer on, enable, speed. Okay, timer on, enable, switch, and here is the PV, yes, that we want to set, right? So follow instruction, we can push F1 to see the instruction. Here is the diagram instruction that explain about the on delay time. Yes. So this address, if we would like to put, we can put S5 time. Yes. 2 sec. It means that 2 seconds. So we can put S5 time 5 seconds or 10 seconds like this. Okay, and this is the number of timer. Example, I will start from T0 here. It means that timer 0. And here is the output for turn on when the time is up. So let me choose coin. Example, I will use the digital output. Yes. So it will start from, yes, this is the input, right? Output the same here. Let's see Q 136.0 until 137.7. Yes. So we can put Q 136.0, right? 136.0, it is the digital output number 0. So here we can comment. Example, lamp 1 status, okay, or motor 1 status. Okay, so we can use it. Yes, if we use like this, let me download the logic and then show to everyone. Yeah. So here we can 0 and we can enable for 1. Let's see, the timer is count. After 10 seconds, it will turn on the output, right? Okay, so output is turned on. Okay, so we need to set the delay time from the HMI, right? Okay, so we need to set like this from HMI. So we need to put the address. Yes, example MW MW50. Yeah, example MW50. So we can set the actual value from the HMI. Yes, if we use like this. Okay, so here we can set. Yes, example we can set from the online monitor, right? MW50. It is the decimal, right? Example, I set 50. 32 millisecond, right? Sorry, 320 millisecond, right? Okay, so we can set from the HMI. So continue, we will go to the network 2 and then insert one more network for timer off. Link to HMI. So let's go to off delay time here. Okay, and then I will use for disable, right, for off delay time. So here I can use M0.1 and here I can use MW60. Yes, and start from T1, right, for timer off. And here I can use the output for Q136.1. Yes, and we can edit. Example, timer off, disable switch. Okay, and here is the motor number 2, right? Motor 2 status. Okay, and we can go to save and then go to download and online. Yes. So we can go to WinCC Flexible to create the HMI project and then download to the real HMI, right? Then I will show step by step. So let's go. Okay, so first open WinCC Flexible 2008 with page 5. And then go to create the new project. And here we can choose the correct hardware that everyone have. For me, I will use mobile panel. Let me find the hardware to be the same my panel. Yes, HMI. Otherwise, we cannot download to the HMI, right? If we use the incorrect. Okay. Let me find MP, right? Okay, this is my model of HMI. Yeah, here. Okay. MP27710 in touch here. This is my model. And then let's go to OK. Let me show the model if we download to the HMI. Okay. So first let's go to design to be the same as my first page. Example, I will use timer on tutorial, timer time up status, motor will be green, and this is a timer count and this is timer set, right? So let follow up me step by step. First, if we would like to set the color, the background to be another color, we can go here and then go to background color, and we can choose another background that we want. Example, I would like to use yellow. I can select yellow. Use this color, we can select this color. Okay, I like this color, so I will choose the color, and then we can simulation. Yeah, like this. Okay, simulation. Yes, if we simulation, we can show the actual. Yes, the full screen. Yes, like this. Okay, so first let's go to connection, and then create the new connection. Yeah, link to PLC S7-300. Okay, and here we need to choose the communication driver to correct with another hardware that we use. Example, we can use to with Omron, GE Fanuc, yes, Allen Prale, yes. So we can use. For me, I use S7-300, 400. So we need to select. And for interface, I will use Ethernet, yes, because I use LAN cable connect from my HMI to the PLC, yes, station. So here is the IP address of my PC, yeah. So 192.168.0.1, yes. And here we need to put the IP address of PLC, yes. So 192.168.168.0.1. Okay, it is the IP address of PLC, yes, and here is the IP address of HMI. Okay, and then go to screen again, and then we need to create the text, right? we need to create the text for show the signal of the motor or set and show the status of timer when it count, right? And need to create one more button for enable and disable for timer off, right? I will choose the page number 2 for timer off. Yes. So let's go to create the text. So first, let's create the switch for enable timer on, right? So I will use enable timer on. Yes. And here is the automatically connection. When we create, it will show automatically. And then let's go to Boolean because I use the switch right here. So the address is M 0.0. Yes. We can command example enable timer on switch. Okay. And then let's go to take number 2. Yeah. Take number 2, we need to set point the timer, right? So MW50. So we can use the timer on set. Okay. And it is the we can use the integer. Yes, integer. So MW50, right? Let's test with integer. Example, this one should be timer on setting, right? Okay. Let's go to test. I will test 1 point first. So here we can use the input, right? And then let's choose the take timer on set. And let's go to choose the format, right? Okay, I will use this format. And decimal place should be 2, right? Okay. Let's test whether it work or not. Let's go to property and then go to text and choose this one to center, choose this one to middle, and we can change the font and size to be like this. Okay. And we can simulation. Yeah, adjust simulation to test my take first. It work or not. Yes. And then we will transfer this project to the HMI. It has error, right? Okay. Oh, this one, right? It's correct. So this one should be 253 because this is my computer IP address. Yeah. So let simulation again. Okay, we go. And then we can set example set 50. It's not format, right? Let me choose the another format. Yes. So the format we can adjust to be correct. The format, yeah. I will change to real. Yeah, example we change to real. Real should be MD, right? So we can change to the word MW50, and then we can test again. Example, I set SIC 100. Not yet correct the format, right? Decimal place should be 3 maybe. Okay, let's test for 3 decimal place. Okay, so we need to use the correct data type. So let's go to choose the timer. Yes, we cannot use word or real, so we can use timer and start from MW50 because it is the MW50 here, and then we can simulation again. Okay, so if I set 4, it means that 4 seconds. I set 12, it means that 12 seconds. Yes, if I set 61, it should be 1 minute and 1 second, right? Okay, so that's correct. So we need create more for the status of the motor number 1. Yes, so let's go to text motor 1, and the data type is should be boolean, right? And start from Q136.0. so this is a motor 1 status. Yes, and one more, we need to create the switch for disable timer off, right? So we need to create the time for show, right? So T0 status, it is the time also. Yeah, so T0 timer on status. Okay, and then we need to create the switch for disable the timer off, right? So disable off, it is the boolean also, right? M0.1. Okay, so this one should be disable switch of disable timer on, timer off, sorry, switch. Okay, and then we need to create the set point, right? So offset point, it is the timer also, right, for data type, and address is MW60. And this is should be timer off setting. Yes, and one more for stator, right? Motor 2. It is the boolean, right? And then the address is q136.1. So select q136.1. Yes, and this should be motor 2 status. Okay, and then we need to create the status of timer, right? So T1 status, the data is timer, and it should be T0, sorry, T1. Timer off status. Okay, so right now that's all. We already create the text, and let's go to create the screen. Yes, so I will use the text command. Example, timer on, config, and testing link with HMI. Okay, I will change to another color, yellow, right? Go to text and then increase the size a little bit to be 20. Okay, 20 not enough, right? So we can use like this. Like this. And link to HMI, right? Okay, can use like this. So we can increase the size, yes, a little bit more. Example 22, 26. Okay. Oh, not enough, right? So we can decrease to 24 as well. Okay, and we can adjust like this, and this one should be 24 also. In this step, everyone can design the style that we want. Yes, and we should have the time up status, right? For motor stator, time count and timer set. Okay, so first I need to create the motor. Yeah, insert the motor from the library. Go to the motor, and then go to the motor here. Yes, drag and drop. Okay, then we will got like this. So we can go to the simple object, and then go to the text file. Example, we can write timer on up I will use white color, right? Timer on up status. Yes. Then it will show the status of the motor, right? Okay. I will increase the font size a little bit more. (22) as well, right? Okay, like this. So we can design the style that we want. And we need to set the timer, right? So set the timer. I will copy. Yeah. Example, everyone can press Control Shift and then drag and drop. We can copy. Yes. So we need to put the text, right? And we can design this one to be good for operation, right? So let's go to property and then go to general. Okay, I will decrease this style. And then I will increase the font size a little bit, right? To be 28. Okay. Okay, 28. And the unit is right? Second. And I will change this one to property and then change this one to be green and change this one to be black and have the solid color with white. Yes, like this. And then we can copy. Yeah, select and then copy, drag and drop to copy. Yes. So this one we have set value, right? So timer on, set value. Okay, timer on set value, and this one should be timer on status or timer on count value. So we can adjust the screen. To be like this. Okay, adjust this one little bit to be like this to a rank, right? Okay, then we can adjust all because we need to resize the motor a little bit. This one should be like this. So for set point we need to set, right? So let's go to general and choose the text. Set point for timer on. Timer on set, right? Here. Yes. And then we need to choose the input because we need to set point. And for output, we choose the output. And this one should be timer on status. So T0 status. Okay. And we need to create one more button for enable the timer, right? So let's go to button. I will use the big button. Example, enable timer on switch. Okay, and then go to property, and then I will change this one to be green color or red color that we want. Example, if the not enable is red color, I will adjust the font size a little bit. 20 maybe okay. Yes, I will put here because we need to put one more button for switch the screen, right? Okay, like this. So we need to configure the button, right, to be enable the timer. Example, let's go to event and then go to click and invert bit. Okay, we use invert bit, and we can choose the text for enable the timer on, right? This text. Okay, and the color animation we can adjust the color. Yes, so we can choose enable timer on and bit. Example, it come 1, it means that it on enable. We can use the color to like this. This one should be the same, right? And the value should be 1. Yes. So we can simulation before download, but we need to create one more page for timer out, right? Okay, let me simulation first. So right now we can simulation. Example, I click yes, the timer start count, right? And example we set 63, so 1 minute, right? And 3 seconds. So it's so long time, right? So I will choose only 10 seconds, and then be enable. Yes. So the timer will count, yes, until 10 seconds. It will on the output, right? And then we will create the color of the motor also. Okay. Good. So let's go to create the stator of the motor when the timer is up. Then we will change the color. Example, the field color I will choose red. Then when it on, I will use the motor 1 status, bit 1. It will change to green, right? Okay. Then we can save the project. Go to desktop and then go to timer. Okay, timer HMI. Okay, and we need to create one more for timer out, right? Okay, I will use one more screen. To create the one more screen easily, we can use like this. Example, I will rename this one to be on screen. It means that timer on screen. Then we can copy and then paste. Yes, so we will got one more screen for timer off. So we can rename off screen. Okay, and then let's go to off screen here. Okay, we will got like this, so we will change only this step. General, change this one to off. Okay, and then we will adjust this font size a little bit. Let's go to font size, maybe 20 is okay, right? Then I will change this one to example maybe 22, still okay, right? Okay, 22 is okay. Then I will adjust this one to 22 also to be similar, right? Okay. Then we can adjust, yeah, this one example, this one adjust, change the text for motor 2, right? Okay. And this one I just change the text also, go to general, and this is the output, sorry, input also, so timer offset point, and this one should be timer 1 status, right? And this one should be, go to color animation to change the color for disable timer off, and then change the event, but bit the same. Then we can choose the text to be correct, so this text, and then change the text to be timer off switch, right? Okay. So when we save and simulation, we can use only one screen, right? Timer on. Okay. We can use only one screen. So we need to create one more button for call the screen for timer off, right? So let's go to timer on, and then I will insert one more button. Example, call timer on screen. Yes, call timer on screen. And we need to configure the screen also, right? So we can go to event, and then go to click and activate screen. So we can choose the screen name. So I will call screen screen this one, yeah, down screen, sorry, call the screen number 2, right? So off screen, this one, and I will change this one to be called timer off screen, because right now we stand on timer on screen, so we need to call timer off screen, right? So basically we can copy and then go to timer off screen and then paste. Okay, and then I will adjust this one a little bit. So this one should be called timer on screen. Okay, then we can save and then simulation again. Make sure we can switch or we can control before we download this project to the real HMI. Okay, so example, I switch to timer off screen, so we can switch and the screen is okay. Let's see, we can simulation before we download. Example, I set 6, okay, so 6 seconds here, disable, or should be change this one to disable timer off, right? So let's see. Okay, so let's me exit again and then change again. Should be disable timer off switch. Okay. Save again. Then we can simulation again to make sure we are configured correctly with the simulation. So let's see, the motor 1 is turned on here. So we disable, it will off, and we can set the value again. Example 5 seconds. And then we freeze enable. So after 5 seconds, it will turn on the motor. Okay, switch to timer off. We can set the timer to be 9 seconds. Then we can disable, and then it will turn off after 9 seconds. So we can switch, yes, timer on, timer off, timer on, timer off that we want. Okay. Example, I set 1 second. Okay. So we need to download this project to the HMI, right? So to download, let's save the project, and then I will show how to download, because we need to set the IP address of the HMI also, right, before download. So I will show how to boot the screen. Yeah, let me close first. So this is the screen. Yeah. So first time we need go to control panel, and then go to the transfer option. We need to choose the correct option that we want. Right now I use the Ethernet. Yes. So if everyone want to use the Ethernet or MPI or USB, everyone can use it. So right now I will use Ethernet because I use the LAN cable. Yes. So we can go to advanced, and then check here. Yeah. We need to put the IP address of the HMI. Yes. That I already show on the slide presentation. 192.168.0.2. Yes. And then let's go exit, and then go exit again. After change, everyone can click OK. Yeah, example, I change this setting to here. I can go to advanced and then change here. Yeah. So we can click OK after change, and then click OK again, and then close it. Yes. Go to File, and then close, and then choose the transfer. Yes. Otherwise, we cannot download it if we not choose transfer, right? So let me download. So go here, and then choose the Ethernet, right? So we need to put the IP address of HMI. So 192.168. sorry, 168.0.2, right? Because we choose .0.2, and we can click transfer and click yes. So the file will transfer from our computer to the HMI. Yes, finish. And the HMI will boot, yeah, automatically. So here we can choose the enable and disable that we want. So let me show the status of PLC also. Okay. So right now we can set point. Example, we set 10 seconds. Enter. And let me show the PLC. When we enter from HMI, here it show 10 seconds also. Yes. And then we can enable. Yes. So the timer will count. After that, after 10 seconds, it will turn on the output right here. Okay. Then we can switch to timer off, and we can set example 9 seconds. And we can disable. Okay. Then we can switch. Oh, cannot switch, right? So let me check the configuration again. Why cannot switch? Go here and then go to the event. Oh, this one, right? So we need to change this one to timer on screen. Yes. So save again. So I need to boot the HMI again before download, right? So let me boot again. Now it's booting. Yes, the system. So we need to freeze transfer again before we download. Otherwise, we cannot download the project to the HMI. Okay. It's booting. So don't forget click transfer. Yes. And then go to our project again. And then transfer again. And click yes again. It will transfer the file again. Okay. After that, we can use again. Example, okay. Let me switch. Okay, right now we can switch from timer on to timer off speed. And here we can set 11 seconds. Enable. Okay, so we can monitor on the PLC also. So if I switch to timer off, yeah, so we can switch. Example, I put 15 seconds. Disable. Yeah, disable. It start count until 15 seconds. The output will be out, right? Let's see. off. And we can speed here. Okay. So this is just example. Yes. So we can speed on and off. So this is just example about how to create the timer to show the value of timer on the HMI, and we can also set point also. Yes, by using the HMI. Yeah. MP277 10-inch touch. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use SIMATIC Manager and WinCC Flexible to configure the analog input module. The first one is analog input module 3317K F02 0AB0. It is the analog input that we can select use for PT100 or thermocouple or current 2Y, 4Y, and also volt DC for input. And here is the analog input, also model 7PF01 0AB0. It is the analog input for only PT100 type. Yes. So there are 8 channels in this module for PT100. So we can connect directly of PT100 to this module, and it will show. Yes. And for this selection, I will detail for how to connect the PT100 or thermocouple 2Y that convert from the thermocouple signal, and then 2Y connect with this module. Okay. So I will detail all for this section, and we will connect with the HMI also. Yes, to show the actual value of PT100 and TC on the HMI. Okay. So first, let me explain a little bit about how to select send for this module, because right now I will use input type for all selection from A, B, C, and D selection. Okay. So let me explain about how to select the hardware. So for channel number 0 and number 1, I will select to A. Yes. A, it means that we can use the 800, 250, 500, and 1000 millivolt. Yes. Or PT100 or TC for this channel. Okay. When we selection to A. And for B, we can use 2.5 volt, 5 volt, 1 to 5 volt, or 10 volt DC. Okay. So I will select to B for channel number 2 and number 3. And for channel number 4 and number 5, I will select to C, and then we can use the 4 wise current, yeah, 4 to 20 milliamp for wise. And for the channel number 6 and number 7, I will select with D. D it means that 2 wise, the same as my slide that I already show. Here is the 2 wise transmitter. So I connect the thermocouple plus and minus to here, and then when we select 2 wise selection of the hardware, it will generate 24 voltage for us. Okay, here is the 24 voltage plus, and here is the 24 voltage minus. Okay, so we will got the supply to the temperature transmitter for 24 voltage, okay, from this terminal. Then if the thermocouple generate the got the hotter or heater, it will connect to here, and then transmitter will generate 4 to 20 milliamp to the analog module. Okay, so this is just summary about how to select. Yes, I will select with 2 options, sorry, 4 options, A, B, C and D. Okay, so that's all for this module. We can select 4 options. Okay, and let's go to how to wiring for module for PT100 and this module also. I will summarize only one page for easy to understand. Okay, so let's go to check together. Okay, here is the detailed drawing of these 2 modules of analog input. The first one is analog input that we select with the 2 wire transmitter here. So I will use terminal number 16 series with the milliamp meter 4 to 20 milliamp. Yes, connect with the terminal number 16 and number 17. I will connect directly to the temperature transmitter 2 wires, because when we select to the 2 wire option for hardware, it will generate 24 voltage here. Yes, to supply the transmitter, and then I will use the TC connect from the sensor to be this terminal, yes, of transmitter. And then for the PT100 we connect like this. Yes, and this is a connection for 0 to 10 volt DC, and here is the current for 4 wires. Sorry, this is a 4 wire, not 2 wire. This is a 2 wire connection. Okay, I will correct this one. This one should be 4 wire. I'm also sorry, this confused. And here is the module of PT100 8 channels. Yes, so we can use for connection 24 voltage for supply, number 21st terminal, and then 40 for minus, and 21st terminal with the plus. Okay, and here is the connection or channel of PT100. The first one, we can jump connection terminal number 3 and number 5, number 4 and number 6, and then the sensor will connect to the number 3 and number 4. Okay, so we can connect like this for all channel of PT100. Okay, and for the address it will generate when I show on the software SIMATIC Manager. Okay, so this is a summary of these two modules, and please this is a 4Y, yeah, not 2Y. Okay, so let's go to see the SIMATIC Manager to config. Yes. Okay, so first I will create the new folder for PT100 or TC testing. Okay, and then I will use SIMATIC Manager and WinCC Flexible to create the new project and simulation the touch panel. And the next video I will download to the actual panel. Okay, so first let's open SIMATIC Manager. Okay, and then I will create a new project. The project name is TC PT100. Yes, browse to find the folder that we already created on desktop here, and then click OK. So first we need to create the new station of SIMATIC S7-300, example TC PT 100. Okay, then let's go to click to hardware configuration, and then we can insert the rack. Yes, for this project decide to be like this, and then go to SM. Yeah, go to insert the CPU. So right now I will use CPU 3140C2PN/DP, the same as the existing video, and here is the IP address. And then let's go to add the two more module of analog. The first one is the analog this module. Yes, here 7K F02, right? So let's go to SM300 AI, and then go to scroll to find the module that made with our hardware. Yes, 7K F02, drag and drop to the rack. Okay, and then we need to selection to be the same as the hardware configuration, right? Okay, let me show the same as here. Yes, here we need to follow up with here. The first one is A, so PT100 or TC, right? Okay, so we can go to double click and then go to the input type. So we can select RTD, and normally I use the PT100 standard. Yeah, and for channel number 2 we select to B, right? So B is 0 to 10 volt. It is correct. Yes, so no need to select. And for channel number 4 and number 5 I will use 2C, right? Select 2C, this one. C it means that 4Y current. Yes, so for Y current I will select to 4DMU. Yeah, for Y current, and start from 4 to 20 milliamp. And for channel number 6 and number 7, I will use 2Y. So I will select 2DM view, 2Y here, current 2Y, and then 4 to 20 milliamp also. Okay, so that all for configuration. We must follow up the selection to be the same hardware that I already explained here. Otherwise, when we download the software configuration to the hardware configuration, it will show SF. It means that fault, system fault. Yeah. So we make sure to select the software to be the same as the hardware. Okay. Otherwise, we cannot download, or it will got SF. Okay, system fault. So that okay, and then we will add one more module for PT100 module A channel, right? 7PF01. Okay, so let me check 7P, right? 7P PT100 here, 0, it is 01. Yeah, it is correct. Yes, and here we need to selection also, but we have only software selection. For hardware we don't have. Yes, so for input we can select here the PT100 type. Actually I always use 3Y. Yes, and the PT100 type is standard. Yes, here. And for other channel, we can selection the same as this channel. Yes. Okay, standard. Okay. And then we can click OK. And then save the project, compile, and then download, right? So before download, we need to connect the LAN cable from our PC to the Profinet port of PLC, right? And don't forget put the manual of our computer. Yes, like this. Example 253. Yes, put like this and then click OK. So we can ping to test. So CMD and then ping 192.168.0.1, right, for our CPU of PLC. So it's so like this, it means that we can communication between our PC to the PLC, right? So we can download. Okay. Run the CPU. Yeah. So right now I will show we don't got the SF. It means that no system fault here. It means that hardware configuration and software configuration is correct. Okay. So let's see here. We don't got the SF fault. Yes. So it means that hardware configuration that we select and software configuration that we download correct and can use properly. Okay. So then the next step we will create the logic or scale to show, right? Okay. So let's go to our block. Open OB1 and then I will use ladder. Okay. So first I will use the PT100 to show, right, for this channel. So start from PIW256. Okay. So for this channel, we can also online here to check. Follow our address. So PIW256. Yes. And we can online monitor. Right now the temperature show around 26.3, right? Okay. So we can get the. So first we need to convert from double integer to double integer, right? We use this one. And then convert to real, right? So di to real, double integer to real, and then divide real, right? Divide by 10.0, right? The same as the previous video for PT100 channel 1 or sensor 1. Okay. Then here is the starting address. Yeah, here PIW256. Yeah, PIW256 here. Okay. So we will put PIW256 and then we can command edit symbol with PT100 or sensor 1. Okay. And here we need to create the temporary variables, right? Let's go to temp and I will use the temporary, yeah, example temp1. It is the double integer, right? So dint. So temp1 here, and we can copy and then paste here. And we need to create one more for real data type, right? Okay. So temp2. It is the real, right? So real. Then we can put temp2, copy and then paste here, and we will show on the HMI, right? So we can use MD 0. Okay. And then we can save and then download to the CPU, and then we can online. Okay. So we will got around 25.6 degrees Celsius, right? For sensor number 1. Okay. So we need to create one more channel, yeah, for 4Y, right? 4Y transmitter, or we can use the standard source loop control or loop testing to use, right? So here we can use the insert the network. Example channel number 4, right? This one. Channel number 3. Yeah, channel number 3, we need to use the example sensor sensor 2 signal 4 to 20 milliamp. Then we can use the FC105, right? That I already explained and tested in the previous video. So we need to convert, right? FC, right? FC 105 here. Okay. Then here is the input, right? So input channel number, let's go to our drawing. Yes, this input for channel number 3, right? It is the for Y. Yes. So for Y we can use the address. So PIW 256, PIW 260, 262, and this is 264, right? 264. So PIW 264. Yes, 264. Right now 20 milliamp. Yeah. I decrease to 4 milliamp. Okay. And then we will got like this. So we can use PIW 264, right? For channel number 3. PIW 264. And then we can use the converter. It is the symbol. Yes. Sensor 2, signal 4 to 20 milliamp, 4Y. Okay, like this. So we can change the symbol to be an integer. Yes. Example, sensor 2, signal 4 to 20 milliamp. Yes. And here is the high scale and here is the low scale. Example, I use 100 for high scale, and here is 0 to 0 for low scale. And for the bipolar, we can use address. Example, M 100.0. Okay. And here is the value. Example, MW 20. And here is the output, right? So example, MD 4. Yes. So we will got the signal like this, and then we can download. Okay. So right now around 0 degrees Celsius. If I adjust, I will test to 20 milliamp. It will show around 100 degrees Celsius. Okay. Let me decrease to 4 milliamp. Okay, we will got 0.05 degrees Celsius. Okay. So that's all for module number 2. And then we will use the module number 3, right? For this one. Okay. For 2 Ys selection. So this is a thermocouple, so we can use the same as this one. So let's create for sensor number 3. Sensor number 3 connect with temperature transmitter 2Y. Yes, this one 4Y, and this one 2Ys. So we can use the converter from integer to double integer. Yeah, this one. And then convert from double integer to real, right? So di to real. And then divide by 10 also, right? Divide real. Okay, divide by 10.0. And here is the address. For address, we will start from PIW to 66, right? Sorry, 260. This is the last one, right? 264, 66, and 68. Okay. So right now the temperature so around around 6.6 milliamp. So this one we cannot do this function. We can use also the same, because we use 2 for 220 milliamp also, right? So we will use the FC105 to convert this one. Okay, so this one should be PIW 268. Yes, 268, and the data type should be integer also. So integer command sensor 3 4Y start from 4 to 20 milliamp also, right? Okay, and this is a rank example. I use 0 to 100 degrees Celsius also. 0 to dot 0 M 100.1 MW 30 MD 8, right? Okay, then we can save and then download. Okay, so right now around 16 degrees Celsius, but the scaling around 150. Yes, let me change the scale. This scale we put the same as the temperature transmitter that set on the setting of transmitter, right? To be the same. Otherwise, it should not the same with the actual temperature. Okay. So in this scale, we need to put the same as the scale that we setting on the temperature transmitter 2Y. Okay. So for module number 1, Yes, module number 1 here we already created. So for module number 2, I just connect only channel number 1, yeah, of PT100. So let's create, go offline, and then insert one more network for signal from module 2 of PT100 sensor channel number 1. Okay. So for PT100 we can use the same as this one. Yeah. So convert from integer to double integer, convert from double integer to real, and divide by 10. Yes, divide real. And then for the address, we can check on hardware configuration. Start from PIW 272, right? So PIW 272. Okay. Right now around 25 degrees Celsius. Yeah. Okay, so this one should be divided by 10.0, and this one should be the address PIW 272. Okay, PIW 272. Okay, and this one we need to create the temp, right? Okay, example temp 3. The data type is double integer. So temp 3 also, yes, and one more for real. So temp 4, it is the real, right? So this one temp 4, and I will use the MD12. Yes. So we can save the project and then download to the CPU. Okay, we will got the actual temperature around 25.4 degrees Celsius. Okay. So for part 1, I would like to explain about like this first. And for part 2, I will convert this one to show on the HMI. And then we can download the real project to the real HMI to show the value. Okay. So I would like to summarize for this section. So first we need to selection to be the hardware of the module, yeah, especially for module number 1, yeah, here we need to selection the hardware to be the same as the software that we already config. Yes, here. Otherwise, if we download to the module, it will show system fault. If we correct, sorry, if we select the incorrect function here. Okay, so it's very important. And for the option that we use to convert, we have two options. The first one, use with PT100 directly. We can use convert from integer to double integer, and from double integer to real, and divide by 10. We will got the actual temperature. Okay. Example, I will hit the channel number 1. Yes, let me hit channel number 1. Yes. Let's see, the temperature is the increase. Yeah. 47. Yes. And for channel number 2, I will hit also. Yes, channel number 2. So if I hit, yes, it will up also, right? Start increase, temperature start increase here. And for channel number 4, right? The new model of analog, I will hit also. Let's see. Okay, 27, 29, I will hit more. 47, right? Start increase. And for this one, for example, for Y, yeah, I will select, yeah, to 20 milliamp, so it will show 100 degrees Celsius. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much. And in the part 2, we will see you again. Okay. Thank you very much again and see you next videos. Bye bye. Hello everyone. Welcome back to my YouTube channel, General Technology Knowledge. Today we will go to part 2 about how to connect the PT100 and TC with the 2Y and 4Y transmitter to the analog input of PLC S7-300. Okay. In the previous video, we already learned about how to link or how to configure from analog input to the PT100 and TC by using the SIMATIC Manager to configure and test it already. Okay. So today we will continue to part 2 about how to link all data to the HMI, okay, by using the WinCC Flexible 2008 for simulation and then download the project to the real of HMI. Okay, so let's go. So first let's open the existing project of SIMATIC Manager project that we already learned in the previous video. Okay, so we can check and then online. Okay, we can online for monitoring the actual value of the temperature for each channel. Yes. So we need to show all these channels to the WinCC Flexible and HMI, right? So we need to create. Double click on WinCC Flexible 2008. And then create the empty project. And right now I will use panel. SIMATIC panel, right? Okay, I will use MP 27710 touch, yeah, for my HMI for connect with the PLC. So let's click OK to create the new device of HMI. And then we need to create the new connection, right? Example PLC1 connection, and connect with the communication driver is S7-300 400, right? So right now I will use Ethernet connection. So here is the IP address of my computer. Yes, 192.168.0.253, 192.168.0.253, and here is the address of PLC. Yeah, IP address. So 192.168.0.1, right? IP address of PLC. And then we need to create the text, right? Follow the program of SIMATIC Manager. The first one is sensor number 1 PT100, so MD0. So let's go to text tab and create the sensor 1. Yes, and the data type is real, right? So real, and start from MD 0. Okay, so we can comment signal of sensor number 1. Yes, okay, sensor 1. And for sensor number 2 is MD20. Yes, sorry, MD4. So next sensor 2, MD4, signal of sensor number 2, and actually we can copy and paste here. So we can rename here to sensor number 3, and the address is MD8. So MD8, change this one to 8, change this one to 3. And for the last one, we can also copy. Yeah, copy, select copy, and then paste here. So sensor number 4, and the address is MD12. So MD12, we will change this one to 12, sensor number 4, right? Okay, actually we can connect another sensors that we want. For channel, sorry, for module number 2, we have a channel. It means that we can use 8 PT100 or 8 sensors. Okay, so right now just example, so I will use only 4 sensors. Yeah, so let's go to screen, and then we can adjust this color to be background like this or like this. Yes, and then we can edit the text. Example, I will use text file. So example, show actual value of PT100 TC on HMI. model MP27710A. Then we can go to property and then go to text, and then we can use the Tacoma ball and then 16. Okay, not enough, right? So we can use like this, and we can delete. We keep only HMI model, yes, like this, and we can delete. Okay, so we can increase the font size to be bigger than this, 22, right? And should be center and should be middle. Okay, so we can adjust the size that we want. Actually, we can use the color. Example yellow, yes, to be clear. Okay, and we need to create the format, right, for sensor. I will use IO file, yes. So we can create only one format and then we can copy and paste. Example 999.99, yes. Go to text, go to Tacoma ball and then use the 22, yes. And we can use the center and also middle, and use the color, right? Go to property, and this color I will use background, I will use black, and text I will use green, yes, like this. If we would like to set the color, we can set also. I already show in the previous video, yeah, show the alarm. So here we can use Y like this. Okay, and then I will copy this text to be sensor 1 PT100, yes, and we can use Y color like this, and for unit we can copy, yes, like this. Copy one more for C. C is capital. Okay, like this. Actually we can group. Okay, so sensor number 1 we already created. Okay, I will adjust to be like this. For sensor number 2 we can copy, yes, select and then copy like this. And for sensor number 3 we can also copy like this. Sensor number 4 can copy like this. Okay, and then we will change this one to sensor number 2, PT100 also, yes. Sensor number 2, it is the PT100, right? Okay, PT100. Sensor number 3, it is the TC. And number 4 is the PT100 also, right? Okay. So we can insert the text. For text number 1, I will use sensor 1. Let's browse the text. Sensor 1. This one should be sensor 2, and the option is only output. This one should be output also. Sensor 2. This one output also. Sensor 3. And this one sensor 4. Okay. And then we can save the project. Yes. Save to keep the desktop and go to TC testing. PT100. Okay. And then we can simulation. Yes. Before go to download to existing our HMI. So we can simulation to make sure the design is correct, yeah, properly before download. Okay, let's see right now. Channel number 1 around 26.7 degrees Celsius. Yeah, here. Channel number 2 around 100 degrees Celsius. Channel number 3 around 26. And channel number 4 around 25. Okay, so we need to download this project to the actual HMI, right? So let me connect the LAN cable. Okay, so right now I already connect the LAN cable from HMI to the PLC, and we need to download the project, right? For HMI, IP address is 192.168.0.2, right? So we can ping 192.168.0.2. Okay. Right now we cannot ping, right? So let me check the LAN cable again. Okay, so let me check ping again. 192.168.0.2, right? Okay, let's ping again. .192.168.0.2, right? Okay, cannot be right now. We can ping. Okay, we can ping, so we can download also, right? Okay. So before download, I will close the simulation. Yes. And we need to click the HMI to be a transfer, right? Let me show. So first we need to click to the transfer, yeah, like this. Actually, we click like this, yeah, transfer when we boot the HMI, yes. And then we can download the project, yes. Okay, can download like this. And we need to choose the Ethernet, right? And put the IP address of HMI. Example 192.168, right? .168.0.2, right? Like this. And then we can transfer and click yes to confirm. Okay. So we will got the project the same as the project on computer, right? Okay. So right now the channel number 1 show around 27, channel number 2 around 100%. So 100 degrees Celsius. So if I adjust this one, yes, like this. And if I hit another channel, yes, let's see, it will go up. Okay, hit another channel. It will go up also, okay. We hit another channel. So this is just example about how to create the project of HMI and then download to show the actual of temperature. Yeah, actually we can online like this, simulation like this, and we can see on the screen also, right? Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye.